Today's video is about one of those rabbit holes that you sometimes fall into. It actually started out fairly innocent. In a recent video, I demonstrated how to use a nifty set of Max for Live devices in order to turn Ableton into an almost fully functional multi-channel DAW. And in that video, I said you could use that in order to create a 9.1.6 Dolby Atmos object bed. And if anybody is interested in me showing you how to do that, let me know and I can make a video. Well, this is this video. In order to show you what I mean, let me demonstrate the end result that we're going to achieve today. Here we have an Ableton session. On this Ableton session we have a track that holds an instance of the instrument tune, which creates a stereo signal. The stereo signal is then routed into a 16-channel track within Max for Live. On this 16-channel track within Max for Live sits an instance of DearVR Pro 2, which is a combination reverb, reflection, room simulation, panner. And that creates a 9.1.6 signal. This 9.1.6 signal can be seen here. I can also add an LFE signal if I want to. So the fourth channel here is going to come in if I add the LFE. And this is then routed into the Dolby Atmos renderer as a 16-channel object bed consisting of 8 channels that are routed into the actual Dolby Atmos bed and 8 channels that are routed into objects that are serving as additional channels for the 16-channel object bed. As it turns out, this is super simple to do, but as always, the devil is in the detail, and man, are there a couple of really interesting details here. So if you are interested in Ableton, Dolby Atmos, or just in things that are weird and unusual to do with digital audio workstations, this is going to be a fun video for you. So let's get started. Let's just jump right into a project. What I have here is a super simple Ableton project with an instance of tune on a track. That's really all I have. And on this instance of tune, I'm just using a very nice one finger preset. And I have a super simple loop here. This loop really consists of only one note, so it's just kind of playing that. And what we're going to do is we're going to turn that into a 16-channel signal in 9.1.6 format, and we're going to use that as an sort of hybrid bed in a Dolby Atmos project with the external Dolby Atmos renderer. Little caveat, because we are working with Ableton and Atmos, we need to use the external Dolby Atmos renderer, and that only really works on a Mac operating system. So for that reason, I'm using a Mac today. However, you can use the exact same trick on Windows as long as you are using the 9.1.6 track for something else. You can't use it, unfortunately, with the Dolby Atmos renderer, but you could use it, for example, with MPEG-H or any other renderer that you want to use, or just as a regular surround sound format. The second thing is that I'm working with Ableton Live 12 Beta today. At the time I'm recording this, version 12 of Ableton Live has not yet been officially released. However, everything that I'm going to show you also works with version 11 just fine. So let's start by turning this track into a 16-channel track, and for this purpose we're going to use the Envelope for Live Max for Live devices. Now in this video I'm not going to talk too much about what exactly Envelope for Live is. I did that in previous videos, and I'm going to leave a link in the description below, and I'm also going to leave some links where you can actually download all these Max for Live devices. They are completely free and open source, and you can just download them and play around with them. In a nutshell, Envelope for Live is a set of Max for Live devices that allow Ableton users to work with Ambisonics audio. Now in this video we're actually not going to use Ambisonics audio. The only thing that we are going to use is we are going to use its capabilities to work with 16 channels, and we're going to repurpose those 16 channels in order to hold not an Ambisonics signal but a 9.1.6 surround sound signal. Before I continue, a quick reminder that if you like this or any of my other videos, please consider subscribing, and I would also appreciate if you could press the like button. It really helps out the channel by scratching the itch of the YouTube algorithm. If you have any questions or comments, please use the comment section below, or also join our Discord community. An invite link is in the description below. And finally, you can now also support this channel by becoming a member, either through the YouTube membership program or through Patreon. Members get additional perks such as access to a private section on our Discord server, early access to my videos, or also access to Zoom calls with me directly so that you can ask me questions or ask me for advice. At this point, a big shout out to our awesome new channel members, Rick Smith, Sam Robertson and P-Works. Thank you so much for your support. This is really hugely appreciated. And with that being said, let's return to our regular programming. So let's add our Envelope for Life devices. And I'm actually not even going to use the official Envelope for Life system. All we're going to do today is we're going to only use the extensions that have been developed by Noah Neumark. I've talked about those extension devices in a previous video, and I'm going to leave a link in the description below here. You don't really need to know exactly what they do and how they fit into the Envelope for Life system. We're just going to use them in order to turn our stereo track into a 16-channel track. You can download these devices for free. Once again, link in the description below, and you put them wherever you want to. I have them here in my user library under Envelope for Life extensions. And the first thing that I'm going to do is I'm going to take a audio injector device, and I'm going to put that after tune. What this audio injector device does is really only take the stereo signal and move it into the 16-channel track that is used within Max for Life in order to route the 16-channel audio in the Envelope for Life system. And then we are going to take the master bus device and we are going to put that on one of our audio tracks. It doesn't really make any difference with audio track you use. I'm going to simply use one of the ready-made audio tracks here. So I'm going to take the master bus device, I'm going to put them on my audio track. And what this master bus device does is it really takes in these 16 channels that are routed through Max for Life and then converts that into something that we can once again either hear or kind of send to an external out. Now, there are a couple of things that we need to set here. First of all, we are not going to work with ambisonics. So what we're going to do is we're going to say no decoder, because once again, no ambisonics, no decoder. We don't need to decode anything. We're going to leave everything else the way it is right now. We're going to make a couple of changes in a second. Then the next thing that I'm going to do is I'm going to add a VST loader device to our track that holds tune. And this VST loader device will hold an instance of DearVR Pro 2, and that will essentially allow us to pan the stereo signal that comes through tune through the audio injector device, then and that will allow us to essentially route that and pan that into our 16-channel audio. So let's add the VST loader device and let's put that right back here. Now, before I add the DearVR Pro 2 plugin, let me first check if everything actually works. So let's press play. And everything seems to work fine. So I have tune here. Tune kind of sends the audio into the audio injector. The audio injector sends the left channel into the first channel of the 16-channel track, the right channel into the second channel of the 16-channel tracks. This reaches the VST loader device. I currently don't have any VST loaded, so this is just routed through. And from there, it is then routed into the master bus device. It comes here on essentially for the first two channels. And then essentially currently I'm just monitoring the first two channels and they are essentially sent out to the audio device. That's really everything I have right now. So the next thing I'm going to do is I'm going to load the DearVR Pro 2 plugin onto the 16-channel track that is routed through Max for Life. And the way this is done is by loading that into the VST loader device that I've just added to my track. And for that purpose, let's go over to the tune track here. And here I have the VST loader device currently empty. And I'm going to load the VST. The way this is done is by selecting the plugin file. On a Mac, you need to go to Library Audio Plugins. And in this folder, you will then find the different plugins. I'm going to use a VST3 version here because essentially it works fine with VST3. As I said in a previous video, you might kind of test which version actually works. Sometimes the VST2 version works and the VST3 version doesn't work. Once again, watch my previous video where I kind of explained the details about that. But for the DearVR Pro plugin, the VST3 version actually works fine. So let's go down to the DearVR Pro 2. Here we have it. And let's open that up. And it's now going to load that into the VST loader device. I'm going to open up the user interface, and the final thing I need to do is I need to switch the output format because currently it is sending that into a binaural stream. So it's not really kind of doing anything in terms of adding channels. What it's really doing is it's turning the stereo signal into a binaural signal. We actually want to have a 9.1.6 signal, and for that purpose we're going to switch the output format to 9.1.6. Because once again, why not? So let's send that to 9.1.6 and let's see if I'm actually getting 9.1.6 at that point. So let's play the audio and let's open up the user interface again. And as you can see here, the plugin is actually receiving the stereo signal. It is converting that into 16 channels. It is then sending these 16 channels into my 16-channel track within Max for Life. And in this 16-channel track within Max for Live, it is then sent to the master device. So here we have the master type device, and this receives these 16 channels. And I'm currently only monitoring the first two, so I'm actually not getting the real impression of what these 16 channels are about. But we will see in a second. There are a couple of things we actually need to do before we can actually get that to work. Now, obviously, if I now go back to the DearVR Pro plugin, I can do all kinds of things. I can move my signal around. I can add an LFE signal. Currently, as you see, the fourth channel is empty, and that is the LFE channel, so I can actually add an LFE signal if I want to. And then essentially I have all 16 channels active. Now, one of the problems that you soon realize is that the order of these channels is a little bit out of the regular order. So let's, for example, change the stereo width here to mono only, and let's just move that around, and let's also turn off the reverb and the reflections so that we only have the actual signal. And once again, we are not really hearing everything because I'm only monitoring the first two channels, and I currently don't have any information on the first two channels. Now, as it turns out, and it becomes, you might already see that here, the left channel actually doesn't come in at where we would normally expect the left channel. The left channel actually comes in here at channel, this is channel number 13. So the channel order is completely out of order, and before we can actually do anything, we need to figure out which channel goes where. And this is what we're going to do next. However, before we do that, let's first set up Dolby Atmos, because once again, we actually want to route it into Dolby Atmos, and for that we need to set up the Dolby Atmos renderer. So let's open up the Dolby Atmos renderer, and here we are, Dolby Atmos renderer. And before I can do anything, I need to make sure that all the settings are correct. So let's first go into the settings of the Dolby Atmos renderer. And the first thing I need to do is I need to make sure that the input device is set to Dolby Audio Bridge, and the output device is whatever output device you're using. I'm also taking note of the fact that I'm working with 30 frames per second. This will become important a little bit later. And I'm expecting the LTC channel, which is the timecode signal channel, on channel 129. Then one additional thing that we need to do is we need to set up the Dolby Atmos renderer to be able to receive 9.1.6. This is not set up by default. If you want to know how to do that, I did that in a previous video, and I'm going to leave a link in the description below where we actually did that. Here, I'm just going to give you essentially the basics. In order to get that going, what you need to do is you need to go into the room setup of the Dolby Atmos renderer. You need to add the channels that are used for a 9.1.6 signal. That you need to add the particular speakers, and it's in this case this is the left wide, the right wide speaker, and then we have the 6 overhead speakers, the two front head speakers, the medium head speakers, the middle head speakers, and the rear head speakers. So you need to add those, and then you need to add a monitoring set or a monitoring layout. And in this monitoring layout, the 9.1.6 layout, you need to select which of the channels are used for that particular layout. So once again, we have these 16 speakers here, and these are essentially what we need to do. So once again, if you want to know exactly how to set that up, I'm going to leave a link in the description below to another video where we actually did that. So with that being said, let's make sure that we have the monitoring set to 9.1.6, and let's hop over to Ableton in order to make the adjustments in Ableton. So the first thing I need to do in Ableton, I need to go into the settings, and in the settings I need to change the output device to the Dolby Audio Bridge. And if you have not done so already, you also need to configure the outputs. And essentially the first 128 outputs are stereo channels, and then the last two, 129 and 130, are mono channels. We are going to use that in order to send the LTC or the timecode information to the Dolby Atmos renderer. So let's leave it like that. Also, always make sure if you're working with Dolby Atmos that you have the sample rate set to 48 kilohertz. Dolby Atmos requires you to have 48 kilohertz, and the buffer size needs to be 512. So those are the typical things you need to set when you're working with Dolby Atmos. There's one more thing I need to do, and that is I need to make sure that Ableton communicates the timecode information to the Dolby Atmos renderer, and this is done by adding the LTC timecode plugin to the set that I have here in Ableton. I'm going to add that here to track number 3. So let's just search for the LTC plugin. Here we have the Dolby LTC generator. Let's add that here to track number 3. I remember that the Dolby Atmos renderer expects a frame rate of 30 frames per second. So let's change that to 30 frames per second. And then I remember that the Dolby Atmos renderer expects that signal to come in at channel number 129. So let's change the output from main to external out, and we're going to change that to 129. And that should now complete the setup, and Ableton is now able to communicate the time for code information with the Dolby Atmos renderer. Now here comes the fun part, because as we have seen, the DearVR Pro plugin is perfectly capable of producing 9.1.6 and sending that into the 16-channel track that we routed through Max for Live. However, the channels were in the incorrect order, so we now need to figure out what channel out of DearVR Pro goes into what channel in the Dolby Atmos renderer. And for that, we first need to figure out what are actually the speaker positions that the DearVR Pro plugin assumes these speakers to be, and how do these speaker positions map onto the speaker positions that the Dolby Atmos renderer expects. To answer the first question, we can simply go into the DearVR Pro user manual, and in the user manual, at the very end of this user manual, so let me just go down here, and we have the multi-channel configuration. So let's go down to page number 54. And here we have the different multi-channel configurations. Now the one that we're going to use is the, the 9.1.6 speaker configuration. That is the standard Nuendo speaker configuration. Here we are. Getting closer, here we are. And here we essentially have the location of those speakers in azimuth and elevation description. And all we now really need to do is need to check where these speakers actually are, which channel they are routed into, and how do they map onto the speaker positions that the Dolby Atmos renderer expects. And for that purpose, what we're going to do is we're going to first of all take one. I'm not going to go through everything in detail, because this is quite tedious. But what I'm going to do is I'm going to show you in one example on how I actually figured it out. And for that example, what I'm going to do is I'm going to simply use the left rear height speaker, and I'm going to show you where actually to find that in the DearVR Pro plugin, and where to find it in the Envelope for Live 16-channel layout. And for that, I just need to take note that the left back height speaker is located at minus 135 degrees azimuth and 45 degrees elevation. So let's put that into the DearVR Pro plugin and see what happens. So we are going to open up the DearVR Pro plugin, and we want to first of all make sure that we have everything down to mono, so the stereo width is set to 0. And then we're going to switch it over to polar coordinates that will allow us to import, or kind of the input, the azimuth and elevation angles. And we said that for the azimuth we have an angle of minus 135, and for elevation we have an angle of 45. And that's pretty much it. We need to make sure that reverb and reflections are turned off, so that we're only getting the dry signal. Once again, because we have not routed anything into the Dolby Atmos renderer yet, you're not going to hear anything, but we should see at what channel this signal is now sent into the Envelope for Live system. So let's press play, and let's see where this channel is sent into. So let's press the play button here, and let's open up the user interface. Now I forgot to turn off the LFE channel, so let's turn it off. And as you can see, the essentially the left rear height speaker is sent into, this is channel number 1, 2, 3, 4, 5, 6, 7, 8, 9. So, and you can continue kind of figuring out where all the other channels go. So for example, if we want to have the right one, so we would kind of change that to 135, and then we see that comes in at number 10 then, and we can do the I don't know, let's use maybe the right middle one, and we see the right middle one is the last channel. And what you have to do is you have to simply go through each and every of those speaker positions and figure out where they are sent into the 16-channel track that is sent through Max for Live. So now that we know where all the individual channels are routed into this 16-channel Max for Live track, we now need to figure out how to correctly route them into the Dolby Atmos renderer. And for that purpose, we're going to divide them into two groups. The first groups will be all those channels that belong to speakers where we have an equivalent speaker in the 7.1.2 layout in the Dolby Atmos renderer. Those we are going to route directly into the Dolby Atmos bed. And then for the speakers that are not in the 7.1.2 layout, we're simply going to add objects in lieu of those speakers. And these objects will sort of serve as an extension to the Dolby Atmos bed. You could call that a hybrid bed or an object bed, or in the Fiedler Audio Dolby Atmos Composer, it's also called a composite bed. Essentially something that consists of channels that go into the traditional Dolby Atmos bed and an additional set of channels that go into objects that sort of serve as an extension to the bed. And this is what we are going to do now. So let's first figure out what are the channels that we can route directly into the Dolby Atmos bed. And for that purpose, let's just look once again at the room setup in the Dolby Atmos renderer. And in the room setup, you see that the 7.1.2 layout, or actually kind of I have a 7.1.4 layout, but it's the same thing. And the 9.1.6 layout essentially share the center channel, the left-right channel, then the left surround, the right surround, and the left rear surround and the left-right surround. So those are 1, 2, 3, 4, 5, 6, 7, and the LFE channel 8 channels that they actually share. The other channels, the left wide and the right wide and the 6 height speakers are essentially channels that are not in the 7.1.2 or 7.1.4 layouts, and for those we actually need to add additional objects. Now, there's one additional thing that I left out here, and that is that I also need to check if the DearVR Pro plugin is actually locating those speakers in exactly those positions where the Dolby Atmos renderer expects them to be. And you can double check that, but you need to believe me that I actually looked into that, and the speaker positions that the DearVR Pro plugin produces are exactly the speaker positions that the renderer expects. So we can simply route them into the Dolby Atmos bed of the renderer and everything will just work fine. So let's close that again and let's hop back into Ableton, and all we really need to do in Ableton is go into the master bus device and select the appropriate external outputs for the individual channels. So these are the 16 channels that are coming in through the Max for Live 16 channel track that essentially holds the DearVR Pro plugin. And what we need to do is we need to simply select where these go. And we are going to start once again with the 8 channels that are going directly into the Dolby Atmos bed, because all we really need to do for those channels is route them to the appropriate outputs. So now I do have already worked it out, and I have a little bit of a cheat sheet here. And kind of if you want to know exactly how that works, you can either follow me along while I'm doing that in this video, or you can also simply go to our Discord server. I'm going to post all the information on our Discord server, and you can download it there. Once again, link in the description below. And there's also going to be a QR code here somewhere so that you can go directly with the QR code. First of all, the first 2 channels go into channel 5 and 6. So let me just maybe move that here to the side a little so that I actually see that. So the first 2 go into 5, 6. Then we have the next one go into 3, 4. Those are actually center channel and LFE channel, so they actually stay where they are. Then we have the next 2 go into 7 and 8. And then we have the left and right channel, for some reason, is here in the back. So 13, 14 go into left and right. And that should complete all the settings that you need to do in order to send everything into the Dolby Atmos bed, or at least the 8 channels that are in the Dolby Atmos bed, to send them in there. Now, the last thing I need to do is I need to switch off the monitoring here, because we're actually going to send that out directly. We don't monitor anything anymore. Now, at this point, I should already be able to get a signal. So let's press play, and I'm currently still not hearing anything, and the reason simply is that I currently have the signal set to one of the height speakers. So let's just kind of move that down again. So let's maybe reset the stereo width and then reset the azimuth. Let's set that back to essentially Cartesian coordinates. And at this point, I already receive some of the channels, and let's see. In the master, they are kind of sent here, and let's see if we get them in the Dolby Atmos renderer. And yes, we are getting some of them in the Dolby Atmos renderer. Now, currently we don't have all the other channels yet. We don't yet have the left wide, the right wide channels, and we don't have the overhead speakers. But we are starting to get some information in there. So the final thing that I need to do is I need to add the remaining speakers, and I'm going to start with the left wide and right wide speakers. And if I look at my little cheat sheet here, so I see essentially that the left wide and the right wide speakers are coming in at channels 11 and 12. So I need to essentially route 11 and 12 into a set of or a pair of objects that are going to represent the left wide and the right wide channel. Now the objects start at 11 and 12. So I'm actually going to route 11 and 12 into outputs 11 and 12. And this will essentially route them into the first two objects. Now, there's one additional thing I need to do now, obviously, and that is I need to tell the Dolby Atmos renderer where these objects actually are. If I'm not telling them, the Dolby Atmos renderer doesn't know how to render them. And in order to tell the Dolby Atmos renderer where these are, I need to add a music penner. So let's add the Dolby Atmos music penner. It doesn't actually make any difference where you add that, can be anywhere. So I'm going to simply add that after the Dolby, the envelope for live master bus device. Doesn't make any difference whatsoever. So this is going to be for the object pair 11 and 12. And essentially what you now need to do is you need to figure out where exactly those speakers are. Unfortunately, the Dolby Atmos renderer cannot work with azimuth and elevation. You actually have to have Cartesian coordinates. Now, the way to figure that out is really just by try and error. So essentially what I did is I just moved things around until I actually had the speakers at the correct position. Once again, I'm going to leave a link to my little cheat sheet, but the cheat sheet essentially says that they are located at -100, 68 and 0 for the left one, and then +100, 68 and 0 for the right one. So what I'm going to do is in the Dolby Atmos Music Penner, I'm going to essentially set that to essentially -100. That's already the case. The Y is going to be 68. And the C we're going to leave at 0, and this is going to be the left wide, and I automatically also have the right wide at that point. And with that, I should already get left wide and right wide speakers as well. So let's just double check. So let's play. And let's see in the Dolby Atmos renderer. I'm currently not yet getting anything because I'm not really moving anything into the left wide and right wide speakers. So let's go back into the penner, and let's maybe what I'm going to do is I'm simply going to enable the reverb. That makes things a little clearer, and let's maybe add a little bit of LFE. And now I have action on all 16 channels, and let's see what we get in the Dolby Atmos renderer. So, and let's see, we already have action on essentially the first 8 channels. With the 8 channels where the 9.1.6 layout overlapped with the 7.1.2 layout. And then I have channels 11 and 12, which are left wide and right wide. And I can actually see in the Dolby Atmos renderer that the left wide and the right wide are now active as well. So the last thing we need to do is we need to do the same thing for the remaining 6 speakers, the overhead speakers, the front overhead, the middle overhead, and the rear overhead speakers. And for that, you also need to figure out where exactly they are in the music penner. And that's actually fairly straightforward because they're located at the corners, at the top corners of the music penner. Now, if you want to figure out where the location of those is or which channel actually routed into those overhead speakers, once again, you try and error. You can simply try to figure out where exactly that signal goes in. I already did that. And the way this turns out is that channels number 7 and 8 are the front overhead speakers. Channels number 15 and 16 are the ones in the middle, and number 9 and 10 are the ones in the back. And we're simply going to add 3 more music penners, and we're going to add 6 more objects. So let's start at the beginning. So once again, first thing we need to route the outputs. So 7 and 8 were the front overhead speakers. So let's route them to 13 and 14, which would be the next 2 objects. Then 15, 16 were the middle ones, and let's keep them in order. So I'm going to use the next 2 channels for that, so 15 and 16, and then we have the rear overhead speakers, which are the next ones that are now routed to 17 and 18. And the final thing we need to do is we need to add the music panner, and we need to add that 3 times. Now, once again, we can add that music panner anywhere we want. Why not use this same track for that purpose? We're going to never change the music panner anyway, because those are more or less fixed objects that are just an extension of the Dolby Atmos bed, so they are not going to be changed in any way, shape or form. So we can simply kind of collect them here after the master bus device. So let's go through them and let's just set them up. So first ones are the front overhead speakers, and these are essentially speakers 13 and 14, and these are just the ones in the front corners. So that's fairly straightforward. So just kind of set that to 100. Then the next ones, let's take the next pair, that's 15 and 16. And that is sort of the ones in the middle. So we set the Y coordinate to 0 and then the C coordinate to 100. And then the last one is the 2 additional ones is 17 and 18. And those are the ones in the back. So the Y coordinate is -100 and the C coordinate is +100. And that's everything there is. And if I'm now playing the signal, I should hear information on all 16 channels. So let's play. So I see in the master, I'm getting all 16 channels in. They are now routed into these 16 channels. So let's look at the Dolby Atmos renderer. And all they are coming in, and I now have information on all 16 channels. And I have divided the 9.1.6 signal into 2 parts, where the first 8 are utilizing the traditional Dolby Atmos bed, and then the other 8 channels are objects. So it's a hybrid bed, a 9.1.6 bed that you can use just like a Dolby Atmos bed. And obviously what we can do now is we can go back into the live setting session and go into our essentially DearVR Pro plugin, and what we can do is we can move that. We just set the Cartesian coordinates and can move that around, stereo width. And that will essentially then give me different impressions. Now, once again, what I'm currently doing is I'm not really monitoring that correctly. So I'm currently only monitoring the 2 channels. So in order to actually monitor that correctly, I would have to switch the monitoring here to stereo. Then essentially I hear that in stereo. But as you can see, everything works fine. And this is really everything there is to it. Now, if you've watched my video until now, you realize that what I said at the very beginning is really true. It's very simple to do, but the details are kind of a little bit tricky to figure out. But once you figure it out, kind of things are very straightforward. You only need to set that once. And if you now want to add an additional track into the Dolby Atmos bed, into the 9.1.6 bed, you don't have to kind of figure out again where all the channels are. All you really need to do is you need to add the DearVR Pro plugin into that envelope for live 16 channel max for live track, and it routes just perfectly fine into the Dolby Atmos renderer. So once you are at that particular point, the remaining things are super simple to do, but getting there was actually a little bit of a challenge. Now, as always, if you have any questions or comments, please use the comment section below or join our Discord community. Invite link is in the description below. And with that being said, see you at the next video.